For this video, we're going to explore solving a three-variable system of equations. You can use the same methods as solving two-variable systems where we use substitution or elimination methods to solve. You can use that same thing and just expand it here to a three-variable system. So I have three equations. So the very first thing I like to do is label each of the equations so that I can keep them in line and keep track of them as I work with them. So 1, 2, and 3. Now here's the thing. Now I need to look and try and find a variable that might help me out. If I look, I have coefficients 3, 2, and -2 on x, 2, -2, and +1 on y, -1, 4, and -2 on z. Because of this, if I look towards the center with my +2y and -2y, those basically I can combine and it would work out very nicely for me. So that's how I'm going to start. Okay. So all I basically want to do is I'm going to move over equation 1, 3x plus 2y minus z equals 1, and I'm going to draw or write equation 2 right underneath. 2x minus 2y plus 4z equals -2. And now comes the point of combining. So I'm going to just draw a bar saying that I'm going to combine my values. 3x plus 2x is 5x. This whole process is to get y to eliminate. So y eliminates. -z plus 4z is +3z. And 1 minus 2 is -1. So at this point that allowed me to eliminate y, but I still have two variables, x and z. So I need to continue here because we're still in two variables. We need to be able to find one solution and work backwards. So now I'm going to come back and looking at the equations I have, if I go back to equation 3, looking at 2 with the -2, 3 has a +1 for the y. So what I want to do is I'm going to multiply equation 3 by 2. 2 times equation 3, which is -4x plus 2y minus 4z is equal to 0. And I'm going to simply recopy equation 2 underneath. 2x minus 2y plus 4z equals -2. And now again I get to combine these. So in combining, negative 4x plus 2x is -2x. My y's eliminate, and in this case my z's actually eliminate. So I end up with the result of -2x equals -2. So this is nice because now I have the single variable x, and it's a quick solve through division. And I find that the actual x value for this system of equations is +1. Now, this is phenomenal because this allows us to continue and solve the rest of the problem. I can apply this +1 into this equation up here and solve for z. So 5 times 1 plus 3z equals -1. That's 5 plus 3z equals -1. Two-step equation. I start by subtracting 5. And that gives me that 3z is equal to -6. And then lastly, divide by 3. Z is equal to -2. So we now have z. So we have x equal to 1. Z is equal to -2. All we have left is to find the value of y. And what's nice is I go back to my original equations and I just need to pick one of the three and use it in order to find the value of y, knowing x and z. So I'm just going to use my top equation, 3x plus 2y minus z equals 1. So I'm just going to start by recopying it. 3x minus 2 plus 2y minus z is equal to 1. Okay. And now I'm just going to substitute the values I know. 3 times x, which x is 1, plus 2 times y, minus z, which z is -2. Working to simplify, 3 times 1, oops, I'm sorry, not done yet. I still need to set it equal to 1. Working to simplify, 3 times 1 is 3. Plus 2y, and then because minus negative, that'll turn into plus 2, still equal to 1. Give myself a little room here. Combining like terms, I could combine my constants. This becomes 2y plus 5 equals 1. And then two-step equation from here. Subtract 5 from both sides. 2y equals negative 4. And then divide by 2, ending with the result of y equals negative 2. And thus, this system has been solved. X is positive 1, y is negative 2, and z is also negative 2. And as I encourage, it's sometimes nice to write the final solution as the understood x, y, z.